Bienvenidos, Ushamdi, and welcome. CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Connecting Networks V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 4.5.1.1, where we're going to be doing the Skills Integration Challenge from Chapter 4. So let's go ahead and dive into this activity. And we're going to get an opportunity now to pull in a lot of our ACL work in addition to some review. If you look here to the right, we're going to be doing some subnetting here. In fact, it's a little, what am I trying to say here? It's going to be a lot of work, actually, from a subnetting perspective. We're going to make this a little easier than what we see right here, because we're going to do some shortcuts to help us out. So let's go ahead and dive in, right? This is a fantastic activity, so let's get things started. Now, the first thing that we're asked to do is to divide the 172.16.128.0/19 into two equal subnets. And so remember, typically what happens is if we have, let's say we have a /24, right? If we have a /24 and I wanted to make this single /24 into two networks, I would create two /25s. Now, how do I do that? Well, remember, it's as simple, and we'll work with the fourth and final octet here. With a /24, the last bits, the last 8 bits, the last octet here is going to be all zeros, right, with a /24. For me to carve this /24 into two separate networks, I need to borrow the single bit, right, this first high order bit here in the last octet, and change it from a host bit to a network bit. And then the rest of these guys here, these are all host bits. Now, we've already seen this in action when we've talked about subnetting and how we determine, okay, where does the network begin and where does the network end? Well, remember, if I'm borrowing this bit right here, the bit position value is 128, right? So if I know the bit position value, and there's a couple of ways we could do this. I could either go work myself backwards by doing 2 to the number of host bits that are left, right? So 2 to the 7 would give me 128, or this bit position right here would give me 128. In both cases, I now know what my block size is going to be. And again, I typically do 2 raised to the power of the number of host bits that are left. So we know that the block size is going to be 128. So if the first subnet, and let's say we're working with the 192.168.0.0/24. Well, this is the fourth octet here, and this is key. I stress this because we're going to be moving into the third octet in that scenario right here, right? So when we look at this, what do we see? We see that we've got this fourth octet as a 0, and that's going to be my first network number. If the block size is 128, I simply increase to 128 for the next network number, but they're no longer 24s, right? They're 2/25s. So the first one would be 192.168.0.0/25. The next one would be 192.168.128/25. So my first usable here would be .1. The last usable would be .126. And remember, I say usable because that's the network ID. 127 is my broadcast address. So down here, we pick up at 128 with the second network in our subnetted out range here. So my first usable would be 129. My last usable would be 254. And 255 is, let me get the 255 down here. 255 is that broadcast address. And again, remember, we're talking about subnetting a Class C address. So we know that for a Class C, the first 24 bits, 8, 8, and 8, these guys are locked in, and then we start borrowing from the host bits. So again, a quick review on the Class C, and that's going to translate to the conversation about the Class B. Now, Class Bs typically cause a ton of confusion because you're dealing with the third octet. And the confusion comes in is where you've got this fourth octet and you're desperately thinking you're going to be doing something with that fourth octet. In some cases you might be, but with a Class B address, right, we're looking at a /19. So what does that look like? So we say 172.16.128.0/19. Well, what are they asking us to do? They're saying to break it into 2 equal subnets. Well, just like a 24 equals 2/25s, right? A 19, we would end up with 2 by /20. And how do we do that? Well, we do the exact same thing that we did with the Class C address, and that is we're going to borrow a host bit and make it a network bit. And we already know the CIDR notation here. And so this is kind of the shortcut way of doing it without getting into all of the binary. So we've got a 19, and what does that look like? Well, 1, 2, 3, 4, 5, 6, 7, 8. These are all network bits, 3, 4, 5, 6, 7, 8. And that's 16, right? So we've got 8 here and 8 here. That is your Class B, right, is a /16. So now we've already borrowed to get to this 19. So we say 17, 18, 19. So we've borrowed these 3 bits here, and that's given us that subnet. But we need to carve that up in half. So we do the same thing. We take the next host bit, which would have been 5 zeros out here. We take that first leftmost host bit and we convert it into a network bit, leaving 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, right? And so this is going to give us the breakdown that we're looking for. And so by borrowing that bit right here, right after the 19 network bits that we already had, we borrow that bit right there. So now the question becomes, okay, we've got 2 to the what? Well, we've got 8, 9, 10, 11. So 2 to the 12 in terms of the number of host addresses that we can have, right? But what we're looking for here is we're looking to determine what is the block size going to be. Now, it's 2 to the 12 if we run it all the way this way, but we just looked at 2 shortcuts. The first one was to look at the bit value position. So the value here is what? 1, 2, 4, 8, and then 16. Okay, and if we looked at just the bits in the octet, we would say 2 to the 4, right? Because it's just the bits that are here. We'd say 2 to the 4 gives us 16. So it's going to be a block size of 16. So how would this get carved up? Well, let me go ahead, and I don't have a lot of room here, so we'll put the first subnet up here. So we'll say number 1. And we already know what that's going to look like. It's just that the subnet mask is going to change. So number 1 is going to be 172.16.128.0/20. Because again, we borrowed that bit, but it doesn't change anything in the 4th octet, right? And we've already got the 3rd octet we're set here. So that's what it's going to be. Number 2 would be we simply add the block size in the 3rd octet, right? Because people typically look at this and they say, oh, 2 to the 12. Well, no, not when we're working out what our CIDR notation is going to be, what that subnet mask is going to be. This is the octet, the interesting octet, which is where we're tweaking the values. And that is where we're going to determine this 16, right? That's how we determine that. So I add 16 to the 3rd octet value that we have here. Remember, with the Class C, we did it over here in the 4th octet. With a Class B, we're interested in that 3rd octet. So number 2, the 2nd subnet we're going to be working with is going to be 172.16. If I added 16 to that, I get 144.0/20. Now, we need to go one further in order to get the range of addresses, right? So we know we add 16 to 128 to get 144. If I add 16 to that, we get 160. So in looking at this, my usable addresses, right? And now the ranges, and this is also what's kind of a little quirky with the Class Bs, is that the range of addresses we end up working with are a little odd sometimes. And so here's what the usable range would be. It would be 172.16.128, and again, I said usable, so .1, and here's where it's a little weird. It's not going to stop at 254. Remember, this is the next subnet. So we're going to run it all the way up to 172.16.143.254. That is the last usable, because 143.255 is the broadcast address for that subnet, right? So this would be with the 255. So 172.16, 143.255 is my broadcast address. If the host IP was that, it would still be that is the broadcast address. Because with that Class B range and a /20, the number of available host IPs is 2 to the 12 minus 2. And so that's a pretty big chunk of IP addresses, right? And you can see that's reflected here. So the next subnet, and I'll crank this guy down here, is going to be 172.16, and these will be the usables, 144. Now 0 is the network ID, so .1. Now remember, it's going to go all the way up to 172.16. What? 144.254? No. Remember, we're dealing with a /20 here. That's the next subnet, so we go all the way up to 159.254. And the broadcast address for, let's say your host address was 172.16.144.9. If that's your host's IP, your host broadcast address would be 172.16.159.255. And so these, based off of these next two questions, it says assign the last usable IPv4 address of the second subnet, and we know that it's 159.254, to the gig 00 interface on branch, and so that would go here, right? And then we're going to have an IPv6 address there. And then assign the last usable IP address of the first subnet, which is going to be 143.254, to the gig 01 interface. But again, don't freak out when you see that Class B, right? And that /18 or /19 or /20. Remember, focus on that interesting octet, that third octet in the Class B address. That is where you're going to be doing all of your legwork. Okay, so we've got our two IP addresses here. And let's make sure that we are good to go. I'm writing these addresses down because there's no way once I erase this I'm going to remember any of this. All right, so we've got it erased. Now let's go ahead and dive in, and we are on the branch router. So let's hit that branch router up. Let's give ourselves a little real estate to work with. And to be honest with you, this is probably the most difficult part of this exercise, is dealing with those Class B addresses. So here we are on the branch router. Let's go from user exec to privilege exec into global config. And now that we've got these Class B addresses and these 2/20 sorted out, let's go ahead and assign these IPs. So we're going to go into interface gigabit Ethernet 00, and let me double check. I think it's the second IP. So 159.254 is going to be what we're working with here. So IP address 172.16.159.254. That is the last usable. Now, a /20, it's pretty straightforward, right? We know the first 16 bits for that Class B address are locked in, and then we borrowed 4 of the host bits to make that /20. So it's going to be the 128 position, the 64, the 32, and the 16, which is going to give us what? 128 and 64 is 192, then 224, then 240.0. So that is our subnet mask. And you see when we hit enter, we should get a few points for that, I would hope. We get 4. So we'll say no shut. It looks like it's up anyway, but I'll say no shut just to be sure. Okay, now we're going to go into interface gigabit Ethernet 01, where we're going to assign the last usable IP out of the first subnet range, which was 172.16. And remember, we ran that all the way up to 143 because 144 started the next network ID. .254, and our subnet mask, pretty straightforward, right? We've already gotten it up above there. 240, let's see, we should end up with a few points out of that, and we do. And so we'll say no shut for good measure. So now we've taken care of the internet addressing. It says document the IPv4 addressing in the addressing table, and that's for your own records, right? So that you have that information there. And configure branch with the IPv4. So we did, right? We're good to go. Now, we get to configure Baker 1, right? Branch 1, I will call, I guess, the branch 1 workstation here. Now, you can see that that range, that is what we broke up. That is what we subnetted, was this 172.16.128. So we've got some additional legwork here. It says, with an appropriate IPv4 address using the first available address of the network to which it is attached. And so here's where we need to mouse over this interface. And my iMac is just, it's on a virtual machine here in Fusion, VMware Fusion. It never shows me the interface. So we need to sort out what interface is that. Is that gig 01 or is it gig 00? Because right now we don't know. Because that addressing information up here that you see, right, in red, that addressing information, that's for the entire /19. We've already carved it up. So which /20 comes off of this interface right here? Well, here's what I like to do just to make sure is I will go into interface, or let's actually, so we're in interface, I guess we'll go 01 as where I think we're at. We'll shut that down first. All right, so we've eliminated 01 as being the interface. Let me bring it up right away here so we'll get the spanning tree working there. So it's not gig 01, which means then by default it needs to be gig 00. So that's the interface we're interested in. Let's say do show run, and let's see what subnet is that in. Well, it falls into the second subnet. So we need to put the first usable IP on branch 1 out of the subnet it sits in, which is the second subnet. So let's come to the desktop. Let's get to our command and control here, and it is going to be 172.16.1. Now remember, it's not 159.1. Where did that range begin? Exactly, it began at 144, because that was the next network after the 172.16.128. So if I'm assigning the first available IP address to the network to which it is attached, it would be 172.16.144.1. And let's see if we get any, yeah, we got the 3 points for that. So, but the subnet, we need to make sure we get this correct, 255.255.240.0. Now, default gateway, what would the default gateway be? It's not going to be 144.1 because we're using that address here. Yeah, exactly. Remember, we assigned the default gateway address to the router interface gig 00. So we already have this information. It's going to be 172.16.159.254. And you can see, wow, the points were, we got points for the subnet, we got points for the default gateway entry. So we got lots of points there. So let's go ahead and put this down and minimize that window. And now let's check. Can I ping? Always a good idea. Can I ping 159.254? And I should be able to get to my default gateway. What about the other router interface that we configured over there, the 143.254? Absolutely. So Baker 1 looks good, right? We're good on host Baker 1. Now, we've been asked to do some IPv6 work here too. So it's asking me to assign, we'll pull Baker 1, pull Baker 1 back up here, we'll get the IP addressing, and now we're going to do an IPv6 address. It says assign to the, oh, I'm sorry, that's going to be the branch. So we're going to come back to B1 here with the IPv6 addressing, but this is going to be on the branch router. So let's pull the branch router back up. And it says we're going to put ACAD Baker 1 and then Baker 2. So this is pretty easy. So we know what interfaces we're going to be working with here. So let's get into gig 00. We're going to say IPv6 address, 2001 DB8, ACAD colon Baker 1, and that's going to be branch 1's interface there, the gig 00, and then it's colon 1. All right, slash 64. So we should see some points from this. I'm just double checking here. Okay, so we should see some points from that, maybe not. Did I get that right? 2001 DB8 ACAD Baker 1 colon 1. Okay, and then gig 01 is going to be IPv6 address 2001 DB8 ACAD colon Baker 2 colon 1. Just double checking here. All right, and oops, sorry, slash 64. And there we go. So we've gotten those two IPv6 addresses configured. Right, now we're going to configure, we configured branch, so now we're going to configure Baker 1 and Baker 2, these workstations, with the right IPv6 addressing. And what is it asking for? Using the first available IP address, first available address of the network to which it's attached. Now remember, we already put the colon 1 on the interface. So if we've already used the colon 1 on the interface, for the router in both cases, what is it going to be? 2001 colon DB8 colon ACAD colon, what did I say? Baker, what are we on? Baker 1 here. Baker 1 colon 2, right? And what is our prefix length? It's a 64. I'm going to come down to the link local address. Now, it didn't give us any clues on the link local address. I'll go ahead and throw FE80 colon 1 in here because it's Baker 1, right? IPv6 gate, I'm sorry, let's do FE80 colon 2 because we're using colon 2. The IPv6 gateway, well, we know what that is. We put that on DB8 colon ACAD. We put that on the Baker 1 colon 1, and no DNS server information provided. All right, so now let's test this out. Let's see, can I ping that address? So ping 2001 DB8. We're going to ping the default gateway address, ACAD colon Baker 1 colon 1. All right, fantastic. We've got connectivity. Now let's get over here to Baker 2, and let's do, whoops, I'm going to get to the desktop. Let's do much the same here. And you can see that Baker 2 has already been assigned the addressing information. And you know, now that I'm looking at Baker 2, you probably could have snuck in here and gotten some information, right? You can see the default gateway and things like that. So this, we didn't put that in there. That was already in there. So you probably could have taken a shortcut and looked at that for the subnetting. But let's focus on this. DB8 colon ACAD colon Baker 2 colon 2 is my first usable. Slash 64 link local, we'll say FE80 colon 2. IPv6 gateway, we know that, right? That's the address DB8 ACAD Baker 2 colon 1, oops, colon 1. And now let's test things out here. Pull up the command prompt. Let's throw our ping command in here, 2001 DB8 colon ACAD colon, what did I say, Baker 2 colon 1. Can I ping that default gateway? And we can. Fantastic. All right, so that takes care of Baker 1 and Baker 2. Document the addressing. So you can see here Baker 1 and Baker 2. There's some spaces you can put that in there to keep track of. Now we're down to HQ and branch. It looks like we're going to be doing some Ospf V2. So we'll start with branch. And let's see how this plays out on the branch router. So I'm reading here to see, let's see what we've got. And we're going to be doing process ID 1, advertise, and these statements here, these are classic Cisco statements. Configure appropriate interfaces as passive. Right? Now, it doesn't tell you which ones to make passive. It just says appropriate. So how are we going to tackle this? Well, let's go ahead and start out. Whoops. Let's go ahead and start out with this. We'll say router Ospf 1. And they don't ask for a router ID to be set, so I guess we're going to let that go. Do not advertise the link to the internet. Well, on branch, that's not a problem. That's with HQ's got the link to the internet. So on branch, we've got these three here, right? These three links. Now, we could say, there's a couple ways we could do this. I could say passive interface default, and then no passive the serial interface. I believe it's probably serial 000. We'll have to check. Or I could simply pick off passive gig 00 and passive gig 01. Now, here's my question to you. Why would I passive the 2 gigabit Ethernet interfaces here on branch? Why would we do that? Exactly. We want them to be advertised, but I don't want OSPF hellos going out these two LAN interfaces on which we have no OSPF speakers. So here's what we're going to do. Let's try it this way. I'll say passive interface default, and let's see if we get points on that. And that's typically how with these activities, there we go. So we could have done it like this, or I could have said passive interface gig 00, passive interface gig 01, and then not said anything for serial 000. But the way we're going to do it here is I'm going to passive interface default, and I'm going to say no passive interface. And let me double check real quick. I think that was what it was. Do show IP interface brief. And it is. So we're going to say no passive interface serial 000. And that is one way to do it. Again, the other way would have been to explicitly say passive gig 00, passive gig 01, and then nothing for serial 000. Now we need our network statements. Now, this should be pretty straightforward. Whoops, not NOET, but network. Should be pretty straightforward. We know the first one's 172.16.128, whoops, 128.0, but here's where we're probably going to have to pause for a second and say, okay, well, this is a little different than the wildcard masks we've worked with before. Remember, the subnet mask, and actually let me put the all 255s up here, 255, 255. Remember, it's the inverse of the all 255's dotted decimal notation. So we know that the subnet, and I'll just do a dash. So we know it's 255, but it's 240.0, right? So if I subtract our real, and remember, it's the /20s here, right? If I subtract the real subnet that we're using right now, which is a 240.0, from the all 255s, we would get 0.0. What is that, 15.15.2, whoops, 255. So a little different than what we've worked with, but just as easy to calculate. So that is going to be the wildcard mask that we're going to be putting for the two network statements. We just need to make sure we get the right networks in there. So it's going to be 0.0.15.255. And did it give us an area number? Okay, so this is interesting. It said configure acumen branch with Ospf V2 according to the following criteria. Didn't give us an area number. So we're going to go with area 0 to play it safe. And let's see, yeah, play it safe with area 0 is usually a safe bet. Now we need the next 172.16. Now what was the next network ID? Remember that block size of 16? Yep, we add it, we get 144.0, because again, the interesting octet, the one that's going to be tweaked and changing, is the third octet for that class B address. Now we already know the wildcard mask, and so we work that in there. And now we need a final network statement, and I believe I'm going to have to do a show run. It's probably it is a /30. I'm sorry, it's right up there on the diagram. So network 192.168.0.0, 0.0.0.3, because remember, a /30 is a 255, 255, 255, 252. So we're familiar with this one here, and area 0. So pretty straightforward, right? Not much. We know router ID that needed to be worked up here. We didn't need to add a router ID, and I'm just looking at the instructions, making sure, because this makes me nervous when they don't put some of these things in here. Set an IPv4 default route on HQ, which is redistributed. Okay, so now we're going to work our way over to HQ. And this is kind of our first touch on HQ. Now, one of the nice things with HQ is that they were kind enough to give you the subnet and the subnet mask over here. You see this? So these two interfaces on HQ, we're not going to have to figure anything out, or we shouldn't have to figure anything out. We should have everything we need to do our configurations, whereas over here, the decision was made to carve that 19 into two 20s. So let's go from user exec to privilege exec into global config. Do show IP interface brief. It should be serial 000, right? And this is, they gave us instructions here. Do not advertise that internet link. We're going to be advertising a default route. So it is serial 000 for the 192.168, and then the 2 gigs. And if I were to say do show run, we should see that in fact on those gig interfaces 00 and 01, we have the dotted decimal notation for the wildcard mask. So for the subnet mask. So to get the wildcard mask, we simply subtract this value from the all 255s, right? Very, very straightforward. So 63.255 will be the last 2 octets in our wildcard mask. And again, like I said, they made it easy. They gave us the network numbers, right? It's always tough when you're you're given this and told, hey, what's the network ID, right? To try to back yourself into what the network ID is here. You've got some legwork to do, but they gave us the 2 network IDs. So let's jump on the OSPF router OSPF 1, and we'll do the same thing. I'll say passive interface default. Let's see if that is what they're looking for here. And it was, and then no passive interface, serial 0, 00000, and that was definitely required because the first network statement I'm going to put in is going to be the 192.168, the low-hanging fruit here, 0.0.0.3, area 0. And what we should see happen is an OSPF adjacency should form between the HQ and the branch. And there we go, right? So do show IP, IP OSPF neighbor. We've got it. What about a do show IP route OSPF? What should I see here? Exactly. I should see the 2/20s that were advertised in the 172.16.128 and the 172.16.144/20 network should be in here. And there they go. You can see it shows as class B. It's been variably subnetted, right? And so here's the first network ID, and then here is the second network ID. And we get there going to, or out, serial 000. All right, so now we need to add in our 2 network statements for our networks. And again, they made it really, really easy, right? So network 172.16.0.0, and we know that it's going to be 0063.255. And that's going to be in area 0 as well. And we know it's 63.265 because we looked at the config on the interface and saw what the net mask is in dotted decimal notation. So that makes this next command even easier. Whoops. Because the block size here is a 64. With that /18, the block size is a 64. And there we go. And so that was the other network statement we needed. Now remember, we were given explicit instructions not to advertise that link to the internet. So the network statements are done. But we've got one more thing we need to take care of, and that's going to be default information originate to send a default route over to the branch. And this is important, right? And let's see, do they have the option here at the end? They don't. So default information originate is very important, right? Because that's going to advertise a default route to the branch. But keep this in mind. If I come to the branch right now, and I say do show IP route OSPF, where is that default route? Why do we not have that default route yet? Exactly. We don't have the default route because we haven't configured it, excuse me, on the HQ router. So we actually need to configure it, and it actually has us do that. Set an IPv4 default route, which sends all traffic to serial 001, which is basically the internet serial interface, this one right here, right? So in order for that to show up on branch, we have to make sure that exists here. So IP route quad zeros, serial 001. We're undoubtedly going to see that message that comes up and talks about the performance issue, which is not an issue here. This is a point-to-point interface, and there it is, right? So that was the command that we needed. Now when I come over to branch, and I say show IP route OSPF, there is my type 5 LSA, the OE2 for the external type 2 route that we get in OSPF because we are redistributing that default static into OSPF. So it comes in as a type 2 external with an administrative distance, as all OSPF routes are 110, and a metric of 1 because it is a default, right? So it comes in with 1. So now, over here on Baker 1, do they give us an IP out here? Do they give us the internet 64? Yeah. So, okay, so here's the default. Well, it's the default gateway. All right, let's try to ping that. So let's come up to Baker 1 here, and let's see, can I ping, and this may or may not work, 64.104.34.1. Chances are we're going to throw an ARP out. It's going to go to that default gateway that we have here on the branch that we've learned from HQ, and it's probably not going to make its way back because it doesn't know how to get back to me. So let's do this. Let's try to ping something over here on HQ. What's HQ2? It's probably a little too adventurous there trying to get out to the internet. So we'll say 172.16.0.2. And this, after some ARPing, should be successful. And there we go. So we've got connectivity from branch 1 now all the way to the HQ office over here to HQ2. But we're not done. Now we get into the last 3 steps here, and these are going to be the ACL. So we're going to design an IPv4 named access list HQ server to prevent any computers from accessing, to prevent any computers attached to the gig00 interface of the branch router from accessing hqserver.pka. All other traffic is permitted. And here we go. Configure the access list on the appropriate router, apply it to the appropriate interface in the appropriate direction. So there's a lot of appropriate things we need to do here. And this is, again, that vague sort of requirement that we end up with here. So let's take a look at this. So if it's going to be applied, or actually it doesn't say apply, sorry. So the branch router, so the HQ server, where's our HQ? So here's HQ server over here. We want to prevent any computers attached to the gigabit Ethernet 00 interface of the branch router. So right here, that interface right there. We don't want any computers attached to that interface. So in other words, Baker 1 and whoever else may be plugged into switch 1 over here. We want to prevent all traffic from that interface that is coming into that interface from accessing the HQ server. So this one is going to be pretty straightforward, and it's called HQ server is the name of it. And so let's think about this. Are they going to want that? Where are they going to want that? I don't think they're going to, yeah, it's on the branch. It's got to be on the branch. Okay, so we're going to put that on the branch router. And let's do this. Let's go ahead and define it here. So IP, remember, named access list. And since we're talking about a destination of HQ server, the host HQ server, it's going to be extended. So IP access list extended HQ. Remember, this is case sensitive. So we need that capital S in there. And we've got to spell it correctly. So IP access list extended HQ server. Now, we are going to prevent, in other words, we are going to deny any computers attached. And I'm trying to make sure we don't have, so all other traffic. So deny IP from any source, right? Because we're going to apply it to that interface in the inbound direction. So deny IP from anybody on that network, on coming in on that interface, getting to, right, from to host. And HQ server is 172.16.0.1. Is that right? Yeah, deny IP coming from anywhere going to host 172.16.0.1. Now, that's going to deny all the traffic, but what do we need to do now? Exactly. It says that even though we're denying all that traffic, for anybody on, and let me make sure I've got this right, is HQ server prevent any computers attached to the gig00 interface on branch router from accessing the HQ server PKA. Is it a special type of traffic? All other traffic is permitted. Configure the access list on the appropriate router, apply it to the appropriate interface in the appropriate direction. Okay, so if everyone is supposed to be blocked, that should be it. So this is kind of an odd one. So permit IP any is the way I'm reading what they're asking for here. But what's odd is it says permit all other traffic, but we're blocking. So here's what I'm struggling with here. It says, and again, it's this vague, it says all other traffic is permitted. But I guess it's all other traffic should be permitted coming from everywhere else is how that's supposed to be. Not all other traffic on that interface is going to be permitted. So that's the ACL, right? So we've got the ACL. Let's get into interface gigabit Ethernet 00, which is where this would get applied. So we're going to say IP access group, and then the name of our ACL is HQ server, and this is gig 00 right here. So we want to get this extended ACL applied as close to the source as possible. And in this case, this is going to work out for us. This will work out for us. And so we're going to say in the inbound direction. So basically, that meets the requirement that all traffic, so if there were other hosts hanging off out here off this switch, right? All traffic coming into that interface, which is the requirement we were given, prevent any computers attached to the gig 00 interface from accessing HQ server, right? And then we're going to allow everything else to go out, right? That's going to do exactly what we want it to do. We're going to do it right here in the inbound direction, because I'm not going to do it here in the outbound direction. And the reason why is because we don't want the branch to have to process all of that traffic and route it only to have it dropped on the egress interface. So we're going to apply it to the inbound interface, and we should see pretty quickly here if we get any points for this from 55 to 60. Okay, we did it right. All right, so we're good to go there, right? We're good to go. Okay, now we're down to this guy here. Design an IPv4 named ACL branch server, right? You got to love these names, branch server. And what are we going to be doing with branch server? With branch server, it looks like we're going to be doing it to the outside. Sorry, I'm thinking to myself here. Okay, prevent any computers attached to the gig 00 interface of the HQ router, right? So the HQ router. So we don't have to shut the interface down. I just need to say, do show IP interface brief. Gig 00 is the 127.254, which is going to be, it falls in this subnet up here, right? So it's gig 00, so it's going to be this link right here. So here's HQ1. So what are we doing? To prevent any computers attached to the gig 00 interface of the HQ router from accessing the HTTP and HTTPS service of the branch server, which is this guy here. Configure the access, and all other traffic is permitted, so configure the access list on the appropriate router, apply it to the appropriate interface in the appropriate direction. So again, lots of appropriate things we need to be worried about here. So we're going to say IP access list extended. We know it's extended because they've given us layer 4. We're going to have TCP port numbers in here that we're going to be dealing with. And this is called branch. Let me make sure I get this correct. BRANCHSERVER. All right, so the first thing that we're worried about is we're going to deny not IP, but TCP. We're talking about HTTP and HTTPS. So deny TCP from anywhere, right? Because we're going to be applying it to that gig 00 interface from anywhere to the host, and that branch server is 172.16.128.1. Now, but we're not done yet, because what are we talking about? We're talking about HTTP and HTTPS. So we'll say www for the first statement. The next statement, there is no WWS or HTTPS keyword. So we've got to know that port number for the SSL, which is going to be 443. So we drop those two statements in there. That takes care of the HTTP. It takes care of the HTTPS. But remember, it says permit IP any. Because we have to allow all other traffic to make its way through the gig 00 interface, which is where this is going to get applied. It's very similar to the ACL that we just did over here on branch, where we're saying that nobody over here can get to that server over there. So we put it on the ingress interface as close to the source as possible. So interface gig 00, where we're going to say IP access group, right? And what was the name? It was branch server. And we're going to do this in the inbound direction, right? We're going to get that traffic as soon as it hits that interface, and we should see a little bump in points, and it takes us to 80. So we've got 20 points hanging out there. And here is the last thing we're going to do. Ipv6 access list, right? This is a really nice activity. We've got two nice IPv4 ACLs that cause us to think about where we're going to put it, how we're going to construct them, and it ends up with an IPv6 ACL. So design an IPv6 access list, name no Baker 1, so no branch 1 is what it looks like, to prevent any IPv6 traffic originating on branch 1 to reach the branch server. So no traffic from branch 1 should reach the branch server. From branch 1 to branch server.pka. Apply the IPv6 access list to the most appropriate location, interface, and direction. So again, they're getting us here. They're killing us with this most appropriate. All right. So let's go ahead and get on the branch router here and get to work. So IPv6 ACL, and let's go exit out of here. So IPv6 access list, and again, we don't have to say standard or extended. We simply put the name, and the name is, and I'm sure they're going to give you points for the name, so make sure you go case sensitive. So IPv6 access list, no Baker 1, where we're going to say, and again, this is what we're doing, we're denying, and it says any IPv6 traffic. Now, the interesting thing is when you say deny, we're not going to say IP, we're going to say, and it's kind of tricky, right? So if I say deny IP and I put the rest of the command in, what is that going to do? And this is a trick question, right? It's a trick question. So remember that iOS, like when I say show IP int brief, so if I said do show IP interface brief, it knows that that stands for interface, and it knows that that stands for brief, and it knows that that stands for show, which is why I can get away with abbreviating the command arguments, right? And the same is true here. If you see this, right, this command, if I were to say deny IP, and we're going to do it to the host, yeah? So we're going all the way down to the 2001, and what, let me reread this, the Baker 1, do we have that up there? We do not, but it was the second IP, 2001 DB8 ACAD Baker 1 : 2. We took the first usable, and the : 1 was already taken, so that's got to be correct. And we're cutting it off from getting to 2001 and the branch server, the address is there. Okay, DB8 ACAD : and was it Baker 2? Yeah, Baker 2 : 3 on this guy here, because the Baker 2 workstation had : 2. Now again, it's not saying HTTP or HTTPS or FTP or Telnet or SSH. It's any IPv6 traffic. So when you look at this command, you may think, whoa, Travis, hold on. You're going to make a mistake here. You're saying IPv4 information, but I'm not, because we're in the IPv6 ACL subconfiguration section, where the only option that begins with the letters IP is IPv6. So don't be fooled by that. In fact, if I pull up a real Cisco router here, whoa, all kinds of log messages going on here. If I pull a real Cisco router up here, and we'll go into global config, and I'll say IPv6 access list, and we'll call it, what was it, no Baker 1, I think was what it was. I'm sorry, yeah, no dash Baker 1. And we get in here, if I say deny ? Are there any other options that begin with the letters IP? There are not. And so iOS is smart enough, just like when you say show IP interface brief, iOS is going to be smart enough to say, oh, yeah, he doesn't mean IPv4, because there is no IP option available. It has to be IPv6, and we should end up with the points once we're done here. So now, again, remember that we need to allow, and let me make sure I get this right. Hold on. Design an IPv6 access list name. No, okay. To prevent IPv6 traffic originating from branch 1 to reach the branch server. No traffic should be permitted from B1 to branch server. But it doesn't say, what about all of the other information, or what about all the other traffic, not information? it doesn't say to allow it. It says no traffic should be permitted between those guys, right? It says no traffic should be permitted between those two, which means traffic should be permitted from everybody else to the branch server. So I'm going to go out on a limb here. They've got to be, I'm almost positive that they're going to want this in here. And again, if I say permit, I can say IP. But what I'm really saying is Ipv6. In fact, when I do a do show run and we'll look at the access lists and things like that, you'll see that it put in Ipv6. So we'll say permit IP any. I'm almost positive it's got to be looking for that. Okay, now remember, what are the three statements at the end of this ACL that we don't see? And I said three. Remember, there are three implicit access control entry statements at the end of this ACL. The first is permit ICMP what? Any, and then it's neighbor discovery, neighbor advertisement, neighbor discovery, neighbor solicitation, and they're permits. Remember that. They're permits, right? Because they don't fall under IP. I should say Ipv6, right? They fall under ICMP in terms of traffic classification. So those are in there implicitly for me, and then there's the deny any at the end. So at this point, we're good with the ACL. I just wanted to make sure I cover that. There's those three implicit statements at the end. So now we need to determine, and this is where it's going to get interesting, as it always does. Now we need to determine where do we put this Ipv6 ACL. You can see we're only 5 points short. I guarantee the placement's going to be our 5 points. At least I hope so. So can we get it as close to the source as possible? Does that make sense? Because if it did, we'd be saying that interface right there in which direction? It would be that interface in the inbound direction, and that makes the most sense. But let's think about this for a second here, because we could do it there in the inbound direction, or we could do it here in the outbound direction. And again, this is one of those cases where an Ipv6 ACL is most synonymous, I said not completely, most synonymous with an extended Ipv4 ACL. And again, the recommended, not the mandatory, the recommended best practice for the placement of an extended Ipv4 ACL, as we've already done twice, right? We just did that twice, is on the interface closest to the source. And we have specifically put host statements in for these two nodes. So the best placement for this, the optimal placement for this, would be inbound on the gig 00 interface, correct? Because if I put it over here on the outbound interface here, traffic from Baker 1 trying to get to the branch server PKA would hit the router. The router would then process that traffic only to drop it in the outbound direction. Because again, remember, the ACL specifically states that host going to this server is going to be blocked. So let's do that and let's see. And I'm a little wary about what's going to happen when we do this, because there was the previous activity where this was not so simple and straightforward. So interface gigabit Ethernet 00. If I say Ipv6, now, is it Ipv6 access group, access class? No. Remember, it's traffic filter, right? So Ipv6 traffic filter, no Baker 1 or no dash Baker 1. And where would we put this on that gig 00 interface? We would put it in the inbound direction. And again, that to me is going to make the most sense here, even though we've already put the other ACL, but that's an Ipv4 ACL on that interface in the inbound direction. Now, I'm waiting for the points to move up, and that is not going to happen here. And this is what I was afraid of. So again, the ACL specifically calls out no Baker 1 coming over here to this server. And then we have a permit Ipv6 any. So that, to me, the optimal interface and keeping with the best practices that we've talked about, and this is achievable by putting that ACL here in the inbound direction. Now, if it's not there, they've got to be saying it's going to be here in the outbound direction. And again, I disagree with that placement. Unless there's something I'm missing, I don't agree with that placement because, again, the ACL is specific to that IP, the IPv6 address and this IPv6 address. So why not put it here and stop that traffic from being processed by the branch router only to be dropped in the outbound direction? To me, that would make more sense. And then let's do this. Let's call that guy back and let's say no, interface gigabit 01. And I guarantee if we do this, this is going to give us the, oh, and this would be in the outbound direction. And that's probably going to do it. Okay, good. Made me nervous there. It's kind of hung up. Okay, so it wants it on the branch router on the gig01 interface in the outbound direction. And again, to me, that is not the optimal placement for that ACL because you're now going to let all the traffic between branch B1 and server or branch server is going to have to be processed here on the branch router only to be dropped in the outbound direction. And again, the routing takes place before the application of the egress ACL. Okay? And so that's why I'm saying that the branch router is going to be forced to deal with all that traffic instead of catching it here in the inbound direction and dealing with it there. Because ultimately we're permitting everything else to go through. So why not put it here? So this, to me, is a better placement of that ACL, but the activity wanted it here in the outbound direction. All right, well, actually, you know, and let's take a look. So do show run, sorry about that. Let me go ahead and show you that even though I put IP in as the argument, it expands it just like it does with the show IP interface brief and any other time you do the like show run, right? That's short for running configuration. So you can see it extended it out here. So be aware of that. You see people will type in, you know, deny IP host 2001:DB8, and you're like, whoa, wait a minute, that's IP. No. The only option there is IPv6. They're just shortening it up. And I want to make sure I cover that so you don't become confused thinking, well, how come you're putting IPv4 but you're using IPv6 addresses? You're saying deny IPv4, but you're listing IPv6 addresses. No, we're not. Remember, that is the only expandable option, IP. If I put IP, it's got to be IPv6. It'll do that for you. So there are the ACLs. There's the information. That is going to do it for Packet Tracer Activity 4.5.1.1. All right, guys, thanks for watching. I will see you on Tuesday night.